If you've started keto and you're wondering, why am I not in ketosis yet? Or maybe you're asking, how do I switch faster without feeling awful? Let me reassure you, ketosis is not magic. It is biology, and biology follows rules. Today, I'm going to show you 8 powerful research-backed tips to get into ketosis quickly, safely, and in a way your body will thank you for. Let's train your metabolism the right way. Ketosis does not begin with eating less. It begins with lowering insulin, the master hormone that decides whether your body stores fat or burns it. For decades, we were told weight loss is about calories, but research in metabolic science shows hormones control where those calories go. Insulin's primary job is not just to lower blood sugar, it is to lock energy inside fat cells. Every time carbohydrates are eaten, insulin rises. And when insulin stays elevated, fat burning is biologically blocked. This is not opinion. This is physiology documented in endocrinology textbooks for generations. When insulin is high, lipolysis, the breakdown of stored fat, is suppressed at the cellular level. It does not matter how motivated you are, fat cells will not release fuel under high insulin conditions. Modern diets keep insulin elevated from morning until midnight through frequent meals, snacks, and hidden sugars. Most people believe ketosis fails because carbs were too high. But the truth is more shocking than that. Ketosis often fails because the body is underfed on fat and depleted of electrolytes at the exact moment it needs them most. When carbohydrates are removed, insulin drops, and this hormonal shift immediately changes how the kidneys handle minerals. Within days of lowering carbs, sodium excretion rises dramatically, a phenomenon well documented in low carbohydrate clinical trials. This is not subtle. Some studies show sodium losses increase enough to significantly reduce blood volume. Where sodium goes, water follows, and the rapid weight loss celebrated in the first week is largely water leaving the body. But water carries more than weight. It carries electrolytes that power every electrical impulse in your system. The brain runs on electrical signals. The heart beats because of electrical gradients. Muscles contract through electrical exchange. Willpower is not what drives ketosis, biology is. And biology responds to signals far more than motivation. You can count every carb, measure every gram, and still struggle if your lifestyle is sending the wrong hormonal message. Ketosis is not activated by discipline alone. It is activated by lowering insulin long enough for the body to trust that it can burn fat safely. And 3 of the most powerful signals that accelerate this shift are intermittent fasting, strategic movement, and deep restorative sleep. Intermittent fasting is not starvation. It is a structured pause that allows insulin to fall without interruption. Every time you eat, even small snacks, insulin rises. And as long as insulin is elevated, fat burning is suppressed at the cellular level. Research shows that insulin can remain elevated for several hours after a meal, meaning frequent eating keeps the body in storage mode all day. When you extend the gap between meals, insulin has time to drop to baseline. As insulin falls, hormone-sensitive lipase activates inside fat cells, unlocking stored fatty acids that have been trapped for years. Within 12 to 16 hours of fasting, liver glycogen stores begin to deplete significantly. Once glycogen is low, the body must transition toward fat oxidation and ketone production. Studies demonstrate that even short fasting windows increase circulating ketones measurably, sometimes doubling levels within hours. This is not magic, it is metabolic inevitability when insulin stays low. Fasting also increases growth hormone secretion, which helps preserve lean muscle while promoting fat utilization. At the same time, fasting stimulates autophagy, the cellular cleanup process linked to longevity and metabolic efficiency. Autophagy improves mitochondrial function, and mitochondria are the engines that determine how effectively you burn fat. But fasting alone is not the full story. Movement is the second signal that tells your body it must adapt. When muscles contract, they pull glucose from the bloodstream without needing insulin. This mechanism, documented in exercise physiology research for decades, improves insulin sensitivity almost immediately. A single session of light activity can lower blood glucose and enhance cellular uptake for hours afterward. When you move during early keto adaptation, you accelerate glycogen depletion naturally. Empty glycogen means the body has fewer excuses to avoid fat burning. But intensity matters. High-intensity workouts during early adaptation can spike cortisol, the stress hormone that signals the liver to release glucose. Elevated cortisol can temporarily raise blood sugar and slow the shift into ketosis. Gentle, consistent movement sends a safer message. Walking after meals reduces postprandial glucose spikes significantly, as shown in multiple metabolic studies. Light resistance training improves insulin sensitivity by increasing muscle mass, and muscle is the largest glucose sink in the body. Stretching, cycling, and moderate aerobic activity enhance circulation, delivering fatty acids efficiently to working tissues. Movement tells the body that energy is needed, and when glucose becomes scarce, fat must be mobilized. This reinforces metabolic flexibility, the ability to switch between fuels without crashing. Metabolic flexibility is strongly associated with lower inflammation, improved blood sugar stability, and reduced risk of chronic disease. But there is a third signal that is often ignored, and it may be the most powerful of all. Sleep regulates hormones more profoundly than any supplement or shortcut. Just one night of poor sleep reduces insulin sensitivity measurably the next day. Sleep deprivation increases cortisol, which elevates blood glucose and indirectly raises insulin. High cortisol can blunt ketone production, even when carbs are low. In controlled studies, individuals who slept fewer than 6 hours showed significantly impaired glucose metabolism compared to those who slept 7 to 9 hours. Sleep also regulates leptin and ghrelin, the hormones that control hunger and satiety. Poor sleep increases ghrelin, making you feel hungrier, and decreases leptin, making you feel less satisfied. This hormonal imbalance leads to cravings that feel psychological but are deeply biological. When sleep improves, hunger stabilizes naturally. Deep sleep stages are also associated with improved mitochondrial recovery and cellular repair. Without adequate sleep, the body struggles to complete the metabolic reprogramming required for efficient fat burning. Fasting lowers insulin. Movement depletes glycogen and enhances insulin sensitivity. Sleep stabilizes cortisol and appetite hormones. Together, these signals create a hormonal environment where ketosis becomes not forced, but inevitable. Many people believe entering ketosis quickly is about stricter dieting. In reality, it is about clearer signaling. The body thrives on patterns. When eating windows are predictable, insulin follows a rhythm. When movement is consistent, muscles adapt. When sleep is prioritized, hormones rebalance. The chaos of modern life, constant snacking, prolonged sitting, artificial light at night, keeps insulin elevated and cortisol unstable. This environment makes ketosis feel difficult, not because the body cannot do it, but because it receives mixed instructions. When you stop eating constantly, move daily, and sleep deeply, the confusion ends. Insulin falls reliably. Fat cells release energy without resistance. Ketones rise steadily instead of fluctuating. Energy stabilizes. Hunger softens. Cravings lose their urgency. This is not about suffering through strict rules. It is about restoring biological rhythm. The human body evolved to cycle between feeding and fasting, activity and rest. Ketosis is simply one expression of that rhythm. When lifestyle signals align, adaptation accelerates dramatically. The transition feels smoother. The fog lifts sooner. The scale begins to reflect internal change. And the most powerful realization emerges quietly. You were never broken. Your metabolism was simply waiting for clear instructions. This is not opinion. This is physiology documented in endocrinology textbooks for generations. When insulin is high, lipolysis, the breakdown of stored fat, is suppressed at the cellular level. It does not matter how motivated you are, fat cells will not release fuel under high insulin conditions. Modern diets keep insulin elevated from morning until midnight through frequent meals, snacks, and hidden sugars. Most people believe ketosis fails because carbs were too high. But the truth is more shocking than that. Ketosis often fails because the body is underfed on fat and depleted of electrolytes at the exact moment it needs them most. When carbohydrates are removed, insulin drops, and this hormonal shift immediately changes how the kidneys handle minerals. Within days of lowering carbs, sodium excretion rises dramatically, a phenomenon well documented in low carbohydrate clinical trials. This is not subtle. Some studies show sodium losses increase enough to significantly reduce blood volume. Where sodium goes, water follows, and the rapid weight loss celebrated in the first week is largely water leaving the body. But water carries more than weight. It carries electrolytes that power every electrical impulse in your system. The brain runs on electrical signals. The heart beats because of electrical gradients. Muscles contract through electrical exchange. And those gradients depend on sodium, potassium, and magnesium being present in precise concentrations. When insulin falls and minerals are lost, the body can feel like it is shutting down. Headaches appear. Fatigue deepens. Dizziness strikes when standing. Muscles cramp in the middle of the night. The heart may flutter unexpectedly. Many call this keto flu, but there is no infection, no virus, only an electrolyte imbalance triggered by hormonal change. Research consistently shows these symptoms improve rapidly when sodium intake is increased appropriately. Yet for decades, public health messaging has trained people to fear salt. The average modern adult has been conditioned to believe salt raises blood pressure universally, despite large population studies showing sodium restriction does not benefit everyone equally. During ketosis, sodium is not optional, it is protective. Without adequate sodium, blood pressure can drop too low, reducing oxygen delivery to the brain and creating lightheadedness. Potassium loss compounds the problem. Potassium is essential for stabilizing heart rhythm and maintaining nerve conduction. Even mild potassium deficiency can create profound fatigue and weakness. Magnesium, involved in more than 300 enzymatic reactions, becomes critically important during metabolic transition. Low magnesium impairs ATP production, the molecule that stores cellular energy. Without ATP, cells cannot function efficiently, no matter how many calories are consumed. This is why someone can eat enough food on keto and still feel exhausted. Electrolytes are not minor nutrients, they are electrical infrastructure. At the same time, minerals are being lost. Many beginners make another mistake. They restrict fat out of fear. For decades, dietary fat was blamed for heart disease, and that fear lingers even when carbohydrates are removed. So, carbs are cut, protein stays moderate or high, but fat intake remains low. This creates a dangerous energy gap. Ketones are made from fatty acids. Without sufficient dietary fat, the liver has limited raw material to convert into ketones. Scientific research shows that ketone production increases proportionally with fat availability under low insulin conditions. Remove carbs without increasing fat, and the body feels like it is fasting without fuel. This leads to hunger, irritability, and metabolic stress. Cortisol can rise in response, signaling the liver to produce glucose, which then raises insulin again. The person believes keto is not working, when in reality they are underfueling the system. Healthy fats are not just calories, they are metabolic signals. Dietary fat stimulates satiety hormones such as cholecystokinin, which reduce appetite and stabilize eating patterns. Fat also slows gastric emptying, providing steady energy instead of rapid spikes. In therapeutic ketogenic diets used for epilepsy for nearly a century, fat makes up the majority of caloric intake. These protocols have demonstrated neurological stability in thousands of patients. This is not dietary extremism, it is clinical practice. When fat intake rises appropriately, the liver produces ketones efficiently. Ketones provide a clean-burning fuel that generates fewer reactive oxygen species compared to glucose metabolism. Lower oxidative stress means reduced cellular damage over time, but none of this happens smoothly if electrolytes are ignored. Sodium supports blood volume, potassium balances cellular gradients, magnesium supports energy production and muscle relaxation. Together, they form a foundation that allows fat adaptation to occur without crisis. Bone broth, rich in sodium and trace minerals, has been used traditionally during fasting for a reason grounded in physiology. Leafy greens provide potassium alongside fiber. Avocados supply both potassium and healthy fats in one food. Magnesium supplementation has been shown to improve sleep and reduce muscle cramps in low carbohydrate populations. These are not optional enhancements, they are structural supports. When electrolytes are restored and fat intake is adequate, energy stabilizes. Hunger decreases naturally. Brain fog clears. The dramatic symptoms fade. The body shifts from chaos to clarity. This is the difference between surviving ketosis and thriving in it. Electrolytes prevent unnecessary suffering. Fat provides the fuel for transformation. Together, they determine whether the transition feels punishing or empowering. Ketosis is not achieved by deprivation, it is achieved by intelligent fueling. Remove the hormonal blocker, supply the proper fuel, replace the lost minerals, and the body responds with remarkable resilience. The real failure is not in the diet, it is in misunderstanding what the body needs during change. When fat is embraced and electrolytes are respected, ketosis stops feeling like a battle and starts feeling like balance restored. If you've started keto and you're wondering, why am I not in ketosis yet? Or maybe you're asking, how do I switch faster without feeling awful? Let me reassure you, ketosis is not magic. It is biology, and biology follows rules. Today, I'm going to show you 8 powerful research-backed tips to get into ketosis quickly, safely, and in a way your body will thank you for. Let's train your metabolism the right way. Ketosis does not begin with eating less. It begins with lowering insulin, the master hormone that decides whether your body stores fat or burns it. For decades, we were told weight loss is about calories, but research in metabolic science shows hormones control where those calories go. Insulin's primary job is not just to lower blood sugar, it is to lock energy inside fat cells. Every time carbohydrates are eaten, insulin rises. And when insulin stays elevated, fat burning is biologically blocked. This is not opinion. This is physiology documented in endocrinology textbooks for generations. When insulin is high, lipolysis, the breakdown of stored fat, is suppressed at the cellular level. It does not matter how motivated you are, fat cells will not release fuel under high insulin conditions. Modern diets keep insulin elevated from morning until midnight through frequent meals, snacks, and hidden sugars. Even foods marketed as healthy, like fruit juices and low-fat yogurts, can spike insulin dramatically. Studies show that constant carbohydrate exposure trains the pancreas to secrete insulin repeatedly, leading to chronically elevated baseline levels. Over time, cells become resistant to insulin's signal, forcing the body to produce even more. This cycle is the foundation of metabolic syndrome, type 2 diabetes, and obesity. Ketosis interrupts this cycle not by starving the body, but by silencing insulin long enough for fat to be released. When carbohydrate intake drops below roughly 20 to 30 grams per day, insulin levels begin to fall measurably. As insulin falls, hormone-sensitive lipase inside fat cells becomes active again. This enzyme is the gatekeeper of fat release. Once activated, fatty acids flood into the bloodstream, traveling to the liver. The liver then converts these fatty acids into ketone bodies, an alternative fuel designed by human biology long before processed food existed. This transformation is not cosmetic, it is biochemical. Blood ketone levels rise only when insulin remains consistently low. One high-carb meal can spike insulin high enough to shut this process down for up to 2 days. This is why consistency matters more than perfection. People often believe they are not in ketosis because they are not trying hard enough. In reality, their insulin is simply not low enough, long enough. Even moderate protein in excess can stimulate insulin secretion, though not as powerfully as carbohydrates. This is why ketogenic science emphasizes low-carb, moderate protein, high-fat ratios. It is not extreme, it is strategic. When insulin drops, the kidneys begin excreting sodium and water, a visible sign that hormonal balance is shifting. Rapid water weight loss in the first week is evidence that insulin has fallen. But the deeper transformation happens invisibly inside the mitochondria. Mitochondria increase the enzymes needed to oxidize fat for fuel. This metabolic reprogramming improves flexibility, the ability to switch between fuel sources without crashing. Metabolically flexible individuals show better blood sugar control, lower inflammation markers, and improved energy stability in clinical studies. Lower insulin also reduces the activity of fat storage enzymes while enhancing fat-burning pathways. This dual action accelerates the transition into ketosis. Insulin is not evil, it is essential for survival, but chronic elevation is destructive. High fasting insulin levels have been linked to increased cardiovascular risk independent of blood glucose. Reducing insulin through carbohydrate restriction improves triglyceride levels and raises HDL cholesterol in numerous controlled trials. These improvements are not side effects, they are direct consequences of hormonal recalibration. When insulin falls, hunger hormones begin to stabilize. Ghrelin, the hormone that signals hunger, becomes less chaotic when blood sugar swings are eliminated. People often report fewer cravings not because of discipline, but because insulin stability reduces biological urgency. Lower insulin also reduces inflammation. Research connects hyperinsulinemia to increased inflammatory cytokines that damage blood vessels over time. Ketosis, by lowering insulin, indirectly reduces this inflammatory burden. The brain responds powerfully to this shift. Ketones cross the blood-brain barrier efficiently and provide a steady fuel source that does not depend on constant glucose intake. Neurological research shows ketones may enhance mitochondrial efficiency in brain cells. This is why mental clarity often appears once ketosis stabilizes. But the gateway to all of this is insulin reduction. Without lowering insulin, there is no fat release. Without fat release, there are no ketones. Without ketones, there is no ketosis. This chain reaction begins with carbohydrate restriction implemented consistently. It is not about eating less food, it is about removing the hormonal trigger that blocks fat burning. Intermittent fasting accelerates this process because it extends the time insulin remains low. During fasting, glycogen stores empty, and the body is forced to rely on stored fat. This further suppresses insulin and speeds ketone production. Sleep also influences insulin. Even one night of sleep deprivation reduces insulin sensitivity, raising circulating levels the next day. Chronic stress elevates cortisol, which can indirectly increase glucose and insulin as well. Therefore, ketosis is not a single action, it is a hormonal environment. Lowering insulin requires consistency in food choices, timing, and lifestyle signals. The body responds rapidly when the signal is clear. Within days of sustained low insulin, fat cells begin releasing energy that may have been stored for years. Energy levels stabilize not because calories were slashed, but because access to stored fuel was restored. The scale may move, but the deeper victory is metabolic control. When insulin is no longer chronically elevated, the body regains the ability to regulate itself. Appetite normalizes, energy steadies, cravings diminish. This is not willpower, it is hormonal liberation. Ketosis is not achieved through suffering, but through strategic insulin reduction. And when insulin finally falls low enough, long enough, the body does what it was always designed to do. If you've started keto and you're wondering, why am I not in ketosis yet? Or maybe you're asking, how do I switch faster without feeling awful? Let me reassure you, ketosis is not magic. It is biology, and biology follows rules. Today, I'm going to show you 8 powerful research-backed tips to get into ketosis quickly, safely, and in a way your body will thank you for. Let's train your metabolism the right way.